All right. So we start out with the reading a chart. Okay. Can you read a chart? According to the numerical model, what's the trend in female employees working since 1970? In general, the trend is what's happening. They're increasing. Okay. Generally, they're increasing. When did they have their little blip? 2000 to 2005. So there's an increasing trend of females with a slight drop from 2000 to 2005. In which interval did the percentage change the most? Well, here it changed by how much? 5.6. Was there anything else that big of a change? So from 80 to 85. Okay, just know how to read a chart. Solve algebraically. What's our first step on this one? Get the square root alone on one side. So x plus 3 equals 2 square root of x plus 6. Then what do we do to each side? Square each side. So x squared plus 6x plus 9 equals 4 times x plus 6. So x squared plus 6x plus 9 equals 4x plus 24. Subtract 4x and 24 from each side. So x squared plus 2x minus 15 equals 0. So you get x minus 5 and x plus 5 and x minus 3 equals 0. So x equals negative 5, x equals positive 3. So because a square root is involved, we have to check. We have to plug in and check. So we stick in a negative 5, we get 1 here, we get negative 5 plus 3 here, so we get negative 2 minus 2 is 0. And you go, no, that doesn't work. We stick 3 in, we get 3 plus 3, which is 6, minus 2 times 3, which is 6. 6 minus 6 is 0. Yes, x equals 3, and that's the only answer that works. Okay, so make sure you check your answers. Automobile rental company. Elaine rented a car for 1 day and drove 104 miles. How much must she pay? Well, $35 plus 104 times 0.09. Somebody help me out with a math calculation there. $9.36, something like that. 9 cents a mile times 104. Right? Okay, and then we add that, so it winds up to be $44.36, right? Now, if Ramon paid $75.59, we take 35 plus whatever times 0.09 equals $75.59. Subtract 35, x times 0.09 equals 40.59 and divide by 0.09. So what's 40.59 divided by 0.09? That's over 400 miles, right? I can't hear you. 405.1? 451. All right. There we go. That many miles, and the first one was that many dollars. Okay? All right. Which graph is this? Well, what does a square root function look like? Well, it looks kind of like that, right? Okay. 30 minus 5x could be because we have a negative slope, so that would work. This is a positive slope. This is a positive slope. This is a parabola, so 30 minus 5x. Graph the function. Is this a function or not? Does it pass a vertical line test? Yes, it passes a vertical line test. Is this a function? Does it pass a vertical line test? No, it does not pass a vertical line test. What's the domain of this function? Do we have a square root involved? Do we have a fraction involved? No. Since we don't have a square root or a fraction, it's all real numbers. You can put any number in there and it'll work out. You guys and your noise that you make. All right. So, removable function or non-removable function. So, in general, what does a 1 over x graph look like? You should know that it looks like that. You should know by this time in pre-calc, 1 over x looks like that. Okay? So if 1 over x minus 1, it just shifts this one just up or down or right or left, and it actually shifts it right. So it would be choice B. A is a graph with what involved? Absolute values. This would be an absolute value graph. Okay? C would be a regular, well, it'd be like x squared plus 2x plus 3 divided by x plus 3, where things would cancel out. Okay? And then this would be a third power divided by x. So it is choice B. Okay? Is there a discontinuity at 0 at x equals 0? No. That's not where the discontinuity is. It's at x equals 1. And what type of discontinuity is it? Since it's an infinite one, it is a non-removable. A removable is where there's a hole in the graph. When it's something like this or this, it's non-removable. Okay? All right, local extrema. Okay? So this is 10 by 10, negative 10 by 10. So each of these dots is probably 2, 4, 6, 8. Okay? So 1, negative 1 is this first dot. Okay? Now, what does it look to be? A local what? A local max. 410 is here. What does it look to be? Neither. What does this look to be? A local minimum. Now, where is it increasing? Well, it's increasing all the way to there, and then from there on. Okay? So basically up to 1 and then 7 on. So up till 1 and from 7 on. Where is it decreasing? Well, then it's in between 1 and 7. Okay, when you see these, you're going to get a graph that looks like that or that. And for me, I just plug and chug. Okay? The easiest number to plug and chug would be 0. Because if it's 0, 0, it's this graph. If it's 0, 3, it's this graph. So you stick in a 0, you get 2. Stick in a 0, you get 4. 2 plus 4 is 6. Minus 3 is 3. So it must be choice B. Okay? Now, if you wanted to make sure it wasn't choice C, okay, then you just check like 2. 2 plus 2 is 4, which is 4. 2 minus 4 is negative 2, which is 2. So 4 plus 2 is 6. Minus 3 is 3. So it's there, not up there. So you know you're right. All right. Where is it increasing? Well, once we get to 4, it's increasing, right? So it's from 4 to infinity. Where is it decreasing? Well, it's decreasing until negative 2. So it's negative infinity to negative 2. And where is it constant? From 4 or negative 2 to 4. Okay? Are we good with that? I'm just going to check, making sure increasing, decreasing has brackets. Yes. Increasing, decreasing has brackets. So make sure you use brackets, not parentheses there. All right. What does that graph look like when it goes like this? X cubed. It's a cubic. Okay. Now, it looks like the cubic has just been slid over a little bit. Where is our cubic? It's right here. There's one there and there's one there. Now, it looks like it's slid to the left, not up. So that's why it's not this one. It's this one. Which ones are increasing over their entire domain? And there are 6 of them. Well, what does A do? It makes a V, so it's not A. This one goes like this. Is it always increasing? Yes, it is. This one goes like this. Is it always increasing? Yes, it is. This one, sine. No. E to the x. I think e to the x goes like that, so I'm pretty sure that's a yes. 1 over x. It's always decreasing. This one, that one's a yes. X squared. No. Cosine. No, because it's like that. ln of x. I think so. I think natural log. I think that goes like this, right? Square root of x. Yes. And yes. The greatest integer function. It's a constant a whole bunch. So 1, 2, 3, 4, 5, 6. We got all 6. Okay? All right. Formulas. F plus g of x is simply x squared plus 10x minus 1. The domain for this, anything restrict the domain? No. So it's negative infinity to infinity. F minus g of x is x squared minus 10x plus 1. Again, nothing restricts the domain. F times g of x is 10x cubed minus x squared. Again, nothing restricts that domain because there's no fractions and no square roots. But the last one, we don't have to do the dividing one. So we're good. F of g of x and g of f of x. So f of g of 5. What I would do if I were you is I'd stick the 5 in here right away because you're going here and then whatever that answer is going there. 5 plus 1 is the square root of 6. Put 6 into the f function, or square root of 6 into the f function becomes 6 plus 8, which is 14. Okay? If you put negative 4 into the f function, negative 4 squared is 16 plus 8 is 24. And you stick 24 into this function, you get 5. 15. If you stick 4, 3 in, are you going to get 14? No. It's 16 plus 9, which is 25. If you stick 2, negative 5 in, are you going to get it? 8 minus 15? No. Stick 5, negative 2 in. You get 20 minus 6? Yes, that one works. 5, negative 2. Okay? Parameter. Okay? You stick 4 in here and 4 in here. Okay? So it would be 12 and 25, right? The ordered pair 12, 25. All right. Is this relation a function? Does it pass the vertical line test? No, because the vertical line. Does it have an inverse? Does it pass the horizontal line test? Yes. A function is 1-to-1. Find its inverse and domain. Okay? Its inverse. Well, to find the inverse, you switch x and y around. So x equals 3y minus 9. So then, move the 9 over. X minus 9 equals 3. And divide by 3. So the inverse is x minus 9 over 3. Now, does anything restrict this domain? No. Does anything restrict this domain? No, even though it's a fraction, there's no variable in the denominator. Neither domain is restricted, so it goes from negative infinity to infinity. Okay? Is this function a one-to-one function? Yes, it is. Okay? So then we have the point 0, 0, 1, negative 1. So then to find its inverse, just swap the points to be 0, 0, and negative 1, 1. Well, 0, 0, and negative 1, 1. Well, it's the exact same graph, isn't it? Oh, no. We better go on to the next point. So it'd be 2, negative 8 is a point. So it'd be negative 8, 2. Negative 8, 2. So it'd be choice B, right? So you just take the ordered pairs from this graph and then just flip them around x and y. Okay? Flip the x and y coordinates around. What's the difference between this graph and this graph? Well, if it happens inside, it's the opposite of what you'd think. So instead of moving right 8, you move left 8. And if it happens outside, it should be what it says. So then up by 9. So left 8, up 9. So how do we write this equation with a vertical stretch of 7 and a shift to the right of 8? Well, the shift right of 8 would be x plus minus 8 squared, and a vertical stretch. So if it's a vertical stretch, does it happen on the inside or outside? Outside. So 7 on the outside. So y equals that. Okay, we good? Okay. A of a rectangle whose length is 8 more than the width. The width is x. X plus 8 is here. Okay. How do we find the area? Well, the area is x times x plus 8. Yeah. Or else x squared plus 8x is probably the better answer. X squared plus 8x. An employee's new salary is $16,275 after a 5% raise. What's the salary before the raise? So the salary plus 5% of the salary equals 16,275. So 1.05 times the salary equals 16,275. So if you divide by 1.05, you'll know what his original was. What's 16,275 divided by 1.05? What do you get, Cheyenne? $15,500. Okay? Hey, that's